All right, so this is just a continuation of what we did last Friday. Last Friday, the ones that we factored were the ones that were really easy to factor because nothing was in front of the x squared. But really, these aren't that much more complicated. We're just unmultiplying, right? And so we're figuring out what was there before it was multiplied. Your first term comes from the first two terms being multiplied together. Your last term comes from the last two terms being multiplied together. So there's only one way I could get 5x squared. 5 times 1 is the only way to get 5, right? So it must have been 5x and x. And then I want to get 6. So how could I get 6? 6 could be 3 times 2. 6 could also be 6 times 1, right? Well, in general, you have better luck if you start with the two that are closest together. So I'm just going to go ahead and randomly put 3 there and put 2 here. And then I'm going to check the inside and the outside to see what I get. Because your inside and your outside is what's going to give you the middle term. So if I do the inside, I get 3x. If I do the outside, I get 10x. Do I have enough there? No, I'm trying to get to 17. Also, notice the signs. See how it's adding up to a negative 17, but it's multiplying to a positive 6? So it means that both signs had to have been negative. Okay, but that one didn't work, so let me try another one. Let me try switching it around and saying 5x minus 2 times x minus 3. Now when I check the inside and the outside, I get negative 2x and negative 15x. Is that what I wanted? Yeah. So because they match, I know that I've done it right. And so the factored form would be 5x minus 2 times x minus 3. So here's one for you guys to do on your whiteboards. Okay, so we knew that it had to be 5z and z, right? Because 5 times 1 is the only way to get 5. Okay, and then 3, it's got to be 1 times 3 or 3 times 1, right? Well, I noticed that 16 is really close to 5 times 3, isn't it? So I'm going to stick the 3 out here so that I'm doing 5 times 3 and the 1 here. What do I know about my signs? They all have to be positive. So now if I check the inside and the outside, I get z and I get 15z, and that adds up to 16z, so I know I've done it right. Okay, let's take a look. All right, so now let's go down. Let's skip that one. All right, so now we're going to factor this one. So how can I get 3x squared? It's got to be 3x times x, right? Because that 3 times 1 is the only way to get 3. And what about my 7? It's going to have to be 7 times 1, right? It's another prime number. Okay, so again, let's look at the middle. What's in the middle? 20. Is that really close to 21? Which is what 3 times 7 equals? So where do you think my 7 is going to go? In the first parentheses or the second parentheses? In the second, right. And then my 1's going to go here. Now, before I figure out my signs, well, first of all, what do I know about my signs based on this negative sign right here? They're different, right? One has to be positive, one has to be negative. Because if they're multiplying to a negative, they must have been different. All right, so now if I check the inside and the outside, I get x, and I get 21x. I want it to be a positive 20x, so that means that this has to be positive and this has to be negative. So my 1 is negative and my 7 is positive. Any questions about that? All right then. There's one for you. It's not all that different, so this shouldn't be too hard for you guys. Yeah. It's kind of silly. All right, so I think most of you got there. Again, the 20 is almost 21, so I know the 3 needs to be out here, and the 1 has to be here. So I get x and 21x, but this time I want it to be a negative 20, so my 21 has to be negative, and my x has to be positive, so that should be plus, and that should be minus. All right, let's do one that's not almost exactly the same as the example. Let's do 3x squared plus 5x minus 12. Okay, so it looks like we mostly came up with that answer, 3x minus 4 times x plus 3. Okay, so now we're going to factor with our special patterns. Is 9x squared a perfect square? Yes, it is. Is 64 a perfect square? And when I subtract, what do we call that answer? The answer to a subtraction problem is the difference. So that means this is the difference of squares. All right, so if it's the difference of squares, that means something when we factor it. It means we end up with different signs. Okay, so if we look at this, what's 9x squared? How can I get that? 3x and 3x. And how could I get the 64? 8 and 8. So if I make 1 plus and 1 minus, if I check the inside and the outside, I get 24x and negative 24x. What happens? They just cancel out, and that's why there's no middle term. So whenever you have the difference of squares, you end up having different signs, and you just take the square root of the first and the last. Okay, so that's our sum and difference pattern. All right, and then the other special pattern is when we have a perfect square trinomial. And so when you see that you have a perfect square at the start and a perfect square at the end, you should check to see, okay, is this a perfect square trinomial?
Then go by line.
So I'm going to check it by taking the square root of each of them. Everything's positive, so it would all be plus signs. And so when I check the inside and the outside, does that add up to 20y? It does. So that means it's a perfect square, and so I can write it 2y plus 5 squared. So there's one for you guys to do. All right, so most of you got 6w minus 1 squared, but someone who likes to think outside the box got negative 6w plus 1 squared.
Whoa.
So those are actually opposite binomials. And so just like opposite numbers will square to give you the same thing, like plus 5 squared is the same as negative 5 squared, it's true with the binomials too. So there are 2 possible answers on that one. But most people don't see the second one. Okay. All right, how about if you guys factor that one for me? This one, well, I think you can. Okay, Yeah, 4x plus 1, 4x minus 1. And yes, if you think outside the box, there's a couple other ways you could do that. Okay, so sometimes there's going to be a greatest common factor. So if I look at 5x squared minus 45, it doesn't look like it's the difference of squares, does it? But is there a greatest common factor I could take out? A 5. So if I divide out the 5, then I've got x squared minus 9. Now I have the difference of squares, don't I? And so I can keep factoring, and I get x plus 3 times x minus 3. All right, you guys are going to do this one. Okay, so a lot of you were puzzled because when you factored out the 3, you got x squared minus 8, right? And 8's not a perfect square, is it? So really, at this point, when we're factoring, you would just leave it like that. However, some people like to go even further, and so we did get 3 times, it would have been x plus 2 root 2 and x minus 2 root 2. But I'm not quite expecting you guys to go that far. I would have been okay with this answer right here. Okay? Okay, but good job, Evan. All right, so now, if we're going to solve equations, we're still just doing like we did before. We're factoring it and setting the factors equal to 0. This is no different than what we did before. So if I factor this polynomial, I know it's going to be 3x and x, and 8 is 4 times 2. So if I do 2 times 3, that's only 6, but if I do 4 times 3, that's 12. Which one's closer to the 10? The 12, right? So I'm going to put the 4 out here and the 2 here. And if I check the inside and the outside, I get 2x and 12x. I want it to be a positive 10, so which one's positive? The 4, right? So that this is positive and then this is negative here. So that equals 0. And now I just set each of my factors equal to 0. So 3x minus 2 equals 0, or x plus 4 equals 0. If I add the 2, 3x equals 2, and then when I divide, I get x is equal to 2/3. And here I just have to subtract the 4, so x equals negative 4. So the answer to that is 2/3 or negative 4. Questions there? Okay, so we're running a little short on time, so I'm going to do this one with you guys real quickly. Okay, so now is this one equal to 0? No. So before I can solve it, I can't use the 0 product property if I don't have a 0. So I've got to subtract the 4p from both sides, and I have to add 5 to both sides so that I have a 0 on the right side of my equation. So now I have 5p squared minus 20p plus 20. Okay, so I can factor out a 5, and then I have p squared minus 4p plus 4, right? So, do you guys notice anything about that one? P squared minus 4p plus 4?
If you multiply it out, you get that same answer at top.
Yeah, but that's not what we want to do. What's that going to factor to? It's p minus 2 squared, isn't it? You guys didn't recognize it as a perfect square? Okay, so I'm not done, so stay put. Okay, so can 5 equal 0? No, so I just ignore that. So p minus 2 has to equal 0, and so that means p equals 2. All right, any questions on this? We're good to go? All right, have a great day.